Hello friends, how are you all? Fine? Okay. Now in this video today, we will see about the bar graph. Up till now, we have seen the line graph, scatter plot graph, whisker plot graph, and now we'll go ahead with bar graph. Bar graph is very popular in the statistic. Here, you just draw the bars to represent the data. Now, on the x-axis, we will take, on the x-axis and the Cartesian plane, we will take the informative data. Like month, subject, then name of the participant, right? Days. This informative data will take on the x-axis, while you can say state, district, while on the y-axis we will take numerical data. This is the most popular way to represent the data on the bar graph. Always we will take the vertical bars so that we will take this data on the x-axis while this data on the y-axis. And we can find any information from the bar graph, right? Okay, the width of the bar that we will decide, the length of the bar is according to the numerical data. For example, here is one bar graph is given, that is votes reporting per district. Here is district A. Suppose this is our graph paper. We have district A, B, C, D, E. So I will write this A, B. Okay, we have to extend the data. Here is the x-axis and y-axis. Now, this is our graph paper. On the graph paper, these are the points given. We have to take, this is region for district A, this region for district B, this region for district C, district D, and this is for district E. A, B, C, D, E district is given. Here is number of voters. Number of voters. This is districts is given. Now, here the votes 100. These are the graph point on y-axis. Here is 100, 200, 300, 400, 500, 600, 700 and 800. These are the points given. Now district A. Here's 200 and 300. So we'll take this little much far points so that we can see it easily. We have the enough space now. Here is 100, 200, 300, 400, 500. It just goes up to 600, 700 and 800. 100, 200, 300, 400, 500, 600, 700 and 800 is given. Now for district A, the number of voters are between 200 and 300. This midpoint is 250. And above 250, that is 275. So I just draw here a bar like this. This is the vote cast by 275 or 28, that is 260 or something approximately in district A. Voters are there. In district B it is above 700. So this is 700. So here it is 750. So I will draw this bar up to 750. This is the bar by district A. Vote cast by district B. That is more than 700. Then district C is, above this is 100, it is 150, and above the 150 it is like this. This is 150, above that. This is the bar for district C. The number of voters are 150, more than 150. That is 180 or something. Right? Then district D, it is 425. So it is 400 and 450 below that. Here is district D. Then district E is 450. Above this 450 district is there. So district E is most probably 475 or 480 you can take. So this is called the bar graph. Here is the information given from the bar graph is district A. The number of voters. This is, it is 250, above that is you can take 275. Between 250 and 300, so it is 275. District B, it is 725, it is above the 7, this is 750. So 725 is there. District B, 725 voters are there. District C, it is 175, it is here, district C. This is 175. Then district D, it is 425. District D, above 400, between 450, that is 425. And district E, it is 475. Voters are there. This is the information given. So always this name of the district or any data which gives you the information that you will take on the x-axis, while this number of voters, that is the numerical data, we will take on the y-axis and draw the bar. This is called the bar graph. Keep in mind, you have to keep in mind that this distance between each and every graph should be identical. First of all, distance between the graph, that is distance between the different bar, is identical. You can do with this shaded area for represent your bar. And another thing is that when you take the name of the district on the x-axis, numerical data on the y-axis is a vertical bar graph is there. But the same graph, if you take this name of the district over here and this numerical data over here, it will become this horizontal bars are there. But the vertical bar is easy to read, convenient way to read, and therefore most popularly always this vertical bars are more useful than the horizontal bar. Once again, name of the district is given on the x-axis and the numerical data if we take on the y-axis, then it is the vertical bar graph. But if you take this numerical data on this x-axis and district on the y-axis and then district wise you draw the bar, it becomes the horizontal bar graph. But this horizontal bar graph is not easy to read. It is not intuitive. And therefore, we can use more popularly this bar graph is used only for vertical lines. Vertical bar are used. That is the one thing. The bar graph is the easiest graph, but keep in mind, here is 1 centimeter or 1 box on the graph is left, then between each and every bar, the same space should be there. This doesn't matter that the width of this bar. It is up to you. You can take here mostly that like this is bar. You can change the width of the bar, but the distance between them should be equal. Length of this, height of the bar depends on this numerical data. Width of the bar doesn't matter. You can take any of your choice. So this is the graph of district wise voting is there. This is the graph, right? Okay. Now here on the x-axis we just write the name of the data given, while on the y-axis it is numerical data, so you have to select the scales according to the data, according to the observation. You just select the scale and write down over here, right? Yes. So this is the example of the bar graph. Now we'll go ahead. The another bar graph is given. This is the one example of bar graph. It is very much easier, right? Yes. Then the another example of the bar graph is here it is a theatre club monthly net expense and earning. Net expense and earning. Here it is the name of the month. Here 0, minus 100, minus 200. 100, 200, 300, 400 and 500. This numerical data is on the y-axis. This is expense earning and expense in US dollar. Now here is the month is given, so I'll just take this points or the equal distance to make the bar. Why I will write this points at the equal distance? To make the equal distance between two graphs, right? Yes, two bar. So here is the August, September. Okay, we have to leave one line also. Then right here, don't do that. Now here is okay, August, September, October, November, December, January, February, right? Okay, we have to take smaller distance for the graph so that 12 months should be there with the space. Here is August, September, October, November, December, January, February, March. We'll take some less distance. February, March, April, May. We'll not do that. Then we'll see in the graph paper only. Now in the August, it is given that like this. This is August, right? Then in the September, it is given between, this is 125. Here is 100. This is 50, right? Yes, above 100. So it is 150. So it is 125. This is September 125. We'll write here somewhere August. August is below this. This is positive, this is negative. So this is the earning and here is the expense. So whenever the earning is more, then expense is more, then it is a loss. So it is negative, that is minus 25 is there. So loss is there. Now September 125 positive. Then October it is given 225. October is given 225. But it is positive. October 225. November again it goes to loss. It is 175. This is 150. So here is 175. November goes in loss. It is 175 but minus 175 because it is that expense is more than, this is expense is more than earning. No earning is there in November. In December it is 325. Here 350. So this is 325 in December. This is December. 325 is there. Yes. In January it is minus 100. Again that goes to loss. January minus 100. Then February it is 175. February this is 175. Then in March it is 125. March it is 125. This March 125. In April it is 275. So I'll just write here April is 275. April, this is March now. May, it is in May it is given 375. In June it is again goes to loss. That is minus 75. And July it is 100. Positive 100 is there. So here is the graph for which this is positive gives us earning, negative gives that earning is less than the expense, so it loss. In the different month, the progress of this theatre club is given. So we have to draw the different bar by the shading area. In August it loss, in September this is the monthly expense and this is given. In this August, June, in here it is April, no, in this June, right, January, right, these are the month. This is August, here is January, November and June. These are the month in which they exactly lost. That expense is more than the earning, right? While all the other month has the good earning. This is the graph given of earning versus expense. So these are the different month we'll take on the x-axis and the expense and numerical data will take on the y-axis. If you take this data on x-axis, it will become this horizontal graph, but it is not so useful. It is not so easy to read the horizontally. Instead of that, we'll read it easily the vertical graphs. So here is the graph is given. From the base of that graph, we can solve some questions. We can answer some questions, solve some problems. How to solve it? You just see that. Now question number 1 is, during which of the month of the following month did the theatre club earning not exceed its expense? The first question, earning not exceed. Yes. Yes. The expense. Which are the month in which earning not exceed the expense? That means expense is more. In the simple way, we can say that in which month expense is more than earning. So we have already boxed it. Which are the month? That is August, November, January and June. These are the 4 months in which that loss. That means expense is more than earning. So, in that option is which month is given? Here, August is given. November, January and June is not given. So, the November, August, that is A option is right. Right? These are the 4 options you have, and we have that this 4 month. So, whichever month is given in the option, that will write the answer. Now the next question is, which of the following most closely approximate the net change in the theatre club's finance for the entire year? Here is the second question. Which of the following most closely approximate the net change in theatre clubs? The net change in theatre club finance for the entire year. Finance for entire year. Net change. You know what is net change? That means what? That is net profit or loss. Net change, that is entire year account. That means the net here, in 1 month it gives the profit, in 1 month it gets the loss. So whenever this net entire year you will count, what is the net profit or loss? What is the final account? That is given, you want to find here. So first one, net change find. We want to find the net change, then you just add this whole transaction. That is in which month it is loss, in which month it profit. Therefore, in August it is minus 25 plus 125 plus 225 minus 175 plus 325 plus minus 100 plus 175 125 275 375 minus 75 and 100. We just add this whole. That means we just want to find the net profit or loss. Then we just add this. Month is loss, profit, and agreement, that is last. How to find it? You just add and subtract it. Then by the calculator you will get this answer, $1350. These are the in US dollars. So you can say that is in dollar. So you know what is it? That means here, if you find in which month it gives the loss, in which month this theatre club expense is more, that is here, here, here and here. But in another month, this earning is more than the expense. So ultimately in the entire year, they will get the profit of 1350 US dollar. That is the question, and here is the answer. Then the next question is, okay, so this is the net profit. If it is negative, then it is net loss. By this way we can find the extra information from the bar graph. The another question here is, what was the average net gain or loss per month? Here now, this question is for entire year. Now it is per month. So here the next question is from this graph. Here, what was the average net gain? What was the average net gain or loss per month? Or loss per month for theatre club from beginning of August to the end of December. That we can say from August to December. Here is the net gain or loss. We can find by adding this, but per month, average per month. So how to find the average? That means mean. Average means mean. So how to find this mean? That is August, September, October, November and December. You just add this month. Net profit or loss, that is earning or expense, divide by 1, 2, 3, 4 and 5. That's where you can find the average expense. So here August minus 25, September 125, October 225, November minus 175 and December 325 divided by 1, 2, 3, 4 and 5. This will give you, if only you want to find the profit or loss in 5 months, in total 5 months, so you just add it. But now average profit or loss, average indicate the mean and therefore divided by 5. Here you get this answer is addition 475 by 5 and therefore it is 95. So in this 5 month, the average profit, this is positive. So we can say average profit is $95 per month. One here and here it is loss, but here and here it gains. So ultimately average is a profit. Average he gains the $95 per month from November, that is August to December. By this way we can say this is the correct option. Now here is one example is given on the page number 360, that is the horizontal bar graph is there. So we also see that graph and from that we can find the questions and answer also. Here horizontal, that is, we also discussed it, which is name is now here on the y-axis and numerical data will take on the x-axis, so that it becomes the horizontal bars. Now here is the bear, then lion, here is wolf, then hawk, then porcupine and jaguar. Here is frog. Here the 25 to 300 is given some at the same distance x. Therefore, here it is 25, 50, 70. 100, 125, 150, 175, 200, 225, 250, 275 and 300. Now what is it? Number of vote received. This is number of vote received on the x-axis. This is numerical data is given on the x-axis, while name of the animal, that is mascot animal, here animal selection is there, and votes for the school mascot. Here that data is given. So bear get it here more than 75. Bear get more than 75 data is there. Then lion get 150 data. Lion, this is 150 data is there. Here lion, then wolf get more than 275. More than 275 data. Votes, the wolf get more than 275. Then hawk get 175 and 200. This is hawk. So it is 275. Okay, sorry. It is 175. Hawk is 175 and 200. So this is 175 and 200. Porcupine is 50 and 75. That is between 50 and 75. This is between 50 and 75 gets the porcupine. Jaguar get 75 to 100. 75 to 100. Jaguar get 75 to 100. And frog get 25 to 50. This is 25 to 50. This is called the horizontal bar graph. This is the bar, and we just represent it by the shaded line so that it can visualize easily, represent, right? To represent the bar, we can see these bars. Now some questions is given here. These are the number of votes received by these animals. The question is, by approximately how many votes is hawk mascot beating out the next most popular mascot? Here, we just write the all voters get how many votes. First, bear gets 75 to 100, so we can write it 80. Okay, more than 80 is it 85 or 88, you can write any. Then lion gets 150. Lion get 150. Wolf get 280. Okay. It is more than 275, so it is 280 wolf. Then hawk get 175, say more, that is hawk is 180. You can write approximate values, right? Then porcupine get 50 to 75, that is 60. Porcupine get 60. Then jaguar get, here it is, okay, 90. And frog is 25 to, between 25 to 50 you will write. 25 to 50, you can say 35. Approximate value 35. Now, how many votes is the hawk mascot? Here hawk get the most. Okay, hawk mascot here is, oh, I have